Hey class, so this is Mr. Schmidt with the recap of the December 8th AP Physics lesson where we talked about conservation of energy and the practice problems, number 1, parts A, B, and C. Okay, so what I want to do is go over these examples again and get you ready for our next one. So as you can see in the homework and on the video here, so we have a point with an initial speed at an initial height, okay? And we want to find the speed of the bus at point B. So rather than using their numbers of 50, 55, 60, and 65, I switched and called this 0 and then moved up from there. So mathematically, they'll give you both the same answer, but anytime I have an opportunity that I might be able to multiply something by 0, it's going to save a little bit of algebra on the end. So that's what I'm trying to do, is time equals 0, and at some other point, height equals 0. You could call any of these points 0 and then have negative and positive numbers anywhere along the line. I just chose the lowest point to have 0 potential. Okay, so we're trying to find the bus at point B. Okay, so the idea is that the energy at any one point is going to be equal to the energy of any another point because energy is conserved. They even elaborate in the directions that the engine is disengaged and the bus is coasting with negligible air resistance and friction. That's not entirely realistic. A bus going 60 miles an hour, of course, would have significant air resistance. But it'd be easy to imagine a scenario where the engine was providing the same amount of energy as being lost by air resistance. Okay, so as we set this up, we're going to have to say all the types of energy at A. So all of the kinetic energy at point A and all the gravitational potential energy at point A is going to be converted into kinetic energy at point B or potential energy at point B. Okay, so we can go ahead and start plugging in the equation for each of those units. So notice this bus did not gain or lose any mass along the way, so I didn't have to do mass A and mass B, but that's something that definitely could happen. The other thing that could happen is if you go so far out of height that G is no longer 9.8 and you're now in orbit or some other significantly different height that we can no longer use G is 9.8, that would complicate things. But most things we're going to do are going to be in a classroom scale or something like that, where this is going to be constant, where the object we're working with is going to have a constant mass. So this gives us a pretty good template to work on, where energy is conserved in the entire system. Okay, so remember our goal here is we are trying to find out what the velocity is. That is our goal. Okay, so we're trying to find out this one, and we're going to see what do we already know. Well, we already know that that was 26.82 meters per second. We know that mass equals 10,000 kilograms. And we know, well, so I'm going to use my convention of my heights is 5 and 0, okay? But you could use any other combination as long as you're consistent, okay? Okay, so that is the other alternative here. So now you could plug those numbers straight away into here and solve. You could plug it into here, find that number, and carry that number through for other questions, or you could solve it symbolically. Because this is the first question of a 5-page packet, I want to go through and solve it symbolically so that if I see similar questions, I can use I can pick up anywhere along the system here. So first of all, we notice that mass is true everywhere. So we can have the mass divide out. Okay. Now remember we're solving for velocity of b, so we can subtract this from both sides. Okay, and then that's going to give us 1/2. Okay, now we can multiply both sides by 2. And then finally, we can take the square root of both sides. Okay, and that is going to give me the starting point for this. So we could distribute, we could cancel out. There's more algebra we can play with here, but the fact is I now have VB all by itself. So now I can take the square root of 2 times 1/2 VA 26.82 squared plus 9.8 times 5 meters plus, remember this was 0, 9.8 times 0, which should have been subtracted, by the way. Okay, of course it's 0, so it's not quite as important. Okay, so we're going to take all that, plug it into our calculator, and we should get V of B equals. Okay, so if we look back at the question, it's always good to check to see if did we come up with a reasonable answer. So it started off going this speed, 26.8 meters per second. It sped up going down the hill, and now we think it's going 28.6 meters per second. Okay, that sounds pretty reasonable for our answer. Okay, so that solves for part A. Okay, now we can move on to part B. Okay, so part B asked, is the bus going to fall below this speed and explode? Okay, so there's part B has 2 sub-questions. Number 1, will it fall below this value? And number 2, identify the interval in which it occurs if it does explode. Okay, so that means there's 2 different ways we can do this. We can either look for this, okay, the velocity here, and see if that is below this number. If it is below this, this is our slowest point. So if our slowest point is below this, then it must have exploded. The other thing we can do is just see what our height is where it explodes, in which case it'll be able to answer this part 2 and answer part 1. So that's what I'm going to want to do, is I'm going to want to find the height at which it explodes and see if it falls within the hill. Okay, because then I can answer both questions by doing one set of equations. Okay, so the setup's going to look very similar here. The energy, you can either use this energy or this energy. Some people found that number originally and they can carry that through. Some people started with one or the other. I always like to start with the initial condition because those are the ones that were listed. So I don't have to worry about any rounding errors or calculator errors propagating through my calculations. Okay, so we want to look, they're saying for what interval, so I'm just going to call this the energy of the interval, okay? And again, we know mass equals 10,000 kilograms. We know the velocity at A was 26.82. We want to know the velocity at the interval of 22.35. We know the first height is 5 meters, and the real question is at what interval does it occur? Okay, so that is what we're looking for. So now we can start going through this process again. So again, KE plus PE is going to equal kinetic energy of the interval and the potential energy of the interval. Okay, all right, so now that's still for A. Okay, so just to reinforce, the whole idea is we've done the first 3 steps the same every time, okay? And that's really the advantage of conservation of energy. The advantage of conservation of energy is we can start by saying energy is conserved for all points. And all the energy at one point is going to be equal to all the energy of any other point, okay? So if matter and energy are conserved, then we can keep going through this process and we can keep setting up the same equations, which means you can start moving it forward pretty quickly and struggling with the core of the question sooner, okay? So this is what we don't know, okay? So again, you can start plugging in numbers at any time. I'm going to solve this symbolically, going through the exact same process I did here. Okay, so we can divide both sides by m, and we can jump down right to here again. Okay, so we have our 1/2 v squared plus GHA 1/2 I squared plus. Okay, so we divided both sides by mass. Okay, and that gave us our simplified version. So notice I've skipped this entirely. Okay, again, some people did go through this, solved it, and they found that this is like a very big number. Okay, hint, don't get hit by a bus going 60 miles an hour. It has a lot of energy. It also has a lot of momentum, a lot of force, all bad stuff. Okay, so we could find that number and propagate it out. I just wanted to skip that entirely by dividing my mass. Okay, now we're solving for h. So we're going to take the g. Okay, now I'm going to subtract this from both sides. Okay, and then finally dividing both sides by g. Okay, so we plug in our numbers. There's my speed here. All that is all over. Okay, couple things to keep track of. It's very easy to start going fast and to forget to square something. Okay, make sure you're tracking all those details. When you put it into your calculator, make sure you're very clear with your calculator about order of operations. Okay, if you don't put this in and you put that divided by 9.8, it's only going to carry over to one side. It's not going to divide everything by 9.8. Okay, so this is supposed to be giving us our height. And when we do that and we plug in our numbers, we get what is our number? 16.2. Okay, so what does that tell us? Okay, well, it tells us if the hill is 15 meters tall and it would have to go up 16 meters to slow down, then we've avoided the explosion. Okay, so will the bus fall below the valley and explode? No. Okay, if it was, identify the interval it would occur at the 16.2, or if we use this convention, 66.2 meters. Okay, which we don't have to answer because we never reached that point. It would have been right up there. Okay, all right, so that answers part B. Finally, part C, drive an equation to determine the speed of the bus at any altitude. Okay, so you'll notice we're going to go through the exact same setup for the first three steps. Okay, so we have the first three steps all set up. Okay, we're not in focus. There we go. All right, so we have the first three steps all set up. Okay, the exact same way, only now this time we want the speed for any given latitude. Okay, so we want the velocity for any given altitude or height. Okay, so we want to solve for this, and we want to leave h as h. Okay, in fact, I'm going to leave all of this open. Again, remember, we're going to see a number of questions here. So the more we can leave out to the very end, the better we're going to be able to pick this up and apply it to other situations. So M is going to cancel out. Okay, remember, if we have a rocket ship or something along those lines, it will not cancel out. So we need to keep track and read the question carefully to know when we can apply that. Okay, so we want to solve for this. No, we want to know derive equation to determine the speed with h given. Okay. All right, but they don't tell us what it is at this point, so we're going to leave it as h. Okay, so we're solving for v, so we're going to do 1/2 v squared plus. Multiply both sides by 2. And then take the square root of everything. Okay, before I do that, I'm going to do a little canceling here. That was, okay, this is where you can get in trouble if you don't keep carrying those numbers down. Okay, so I multiplied everything by 2, and then I also pulled the 2 and the g out. Okay, I'm just trying to keep everything, as many things as I could simplified here. Okay, so then finally, if I square root all of this, I'm going to get okay, that would give me the coordinates for the speed for any given coordinate, for any given starting point and any given speed. Okay, and again, if we couldn't use the numbers from this question, but I'm going to leave it right here so that we're ready. Okay, so I tried to pick these questions off of the server based on what AP likes to ask. So they like these questions because this follows a nice energy well situation. So this could be an electron trapped by an electric potential instead of a gravitational potential. And If you strike the match and you add a catalyst, okay, then it can release more energy as it reaches another point. Okay, so this can be applied to a number of different situations once we understand the conservation of energy here. Okay, your homework for tonight is to look at a different type of situation. This has one set of potential energy that will get converted to kinetic, which will convert this guy into his own kinetic energy and into his own potential. Okay, key point about this upcoming assignment, we're going to have to change the masses. Okay, that's the big difference from for number 2 versus number 1. Okay, so with that in mind, hopefully you work on your assignment tonight and you come tomorrow with good questions and can follow along, maybe even you get the answer correct. All right, with that, have a good evening. I'll see you tomorrow.